All right, so this lecture is for April 4th, and what we're going to be doing is kind of just reiterating what we were kind of learning before. Remember that you have closed and open circuits. Only closed circuits work. So that way, like with this picture right here, you have a switch that is open, and so that switch is preventing electricity to flow. So that means that these light bulbs would not turn on because this switch right here is open. So open circuits don't work. And we'll go ahead and we'll label that. That is a switch. And you have two light bulbs that are right here. Light bulbs are a form of resistor. That means that they kind of control the flow of electrons. And again, we're looking at series and parallel. These are both examples of closed circuits that will actually produce electricity, and we can use them, well, actually, depending on the circumstance. There are some circumstances where a series circuit is better, and that is whenever you're dealing with safety issues. But if you have exactly one part of your circuit here that's broken, then the entire circuit fails. So if one light doesn't work, both lights won't work. So that is one of the downsides of a series circuit. Let's say you're working with power tools and one thing didn't work, then it's actually a good thing if the entire thing fails. So that way you're not hurt. But series are dependent on their pathway. Secondly, we're going to look at our parallel circuits. Parallel circuits, you have paths that are kind of going right next to each other. Kind of like your math definition of parallel. They don't touch, they don't intersect, they kind of just move same direction, going on opposite sides of each other. Now, parallel are independent of each other. If one is unscrewed or if one is not working, then that's okay, because if one is not working, the other one will still be brighter. Now, your house is actually wired in a parallel manner, so that way, like if an appliance doesn't work, your whole house doesn't stop working, or if a single light is not working, then your whole house doesn't shut down. So your house is wired in a parallel manner. I'm going to skip down here, and we're going to look at current, voltage, and resistance. Your current is going to kind of be considered like a flow. Like, let's think of water for a second. Water flows, it takes the path of least resistance. So does your current. Your current will flow and take your path of least resistance. And again, your current is going to be moving electrons. And I want for you to think about this. We already know electrons are in the outer orbits of your atoms. That's actually why you get static electricity, because we already know atoms make up everything. Well, even the shirt that you wear or the carpet that you're walking on, you can actually gather electrons from those individual atoms, and those electrons can actually gather in what they either call conductors or insulators. And so when you have electricity kind of building up, or electrons building up, they'll kind of gather around really a good conductor, which is why you have electricity flowing around a wire. It doesn't actually flow through the wire, it flows around the wire. So your current is going to be equal to the abbreviation I, and current is measured in amperes or amps. And if you increase the current, you're going to gain more electricity through a device. If you increase the electricity in the device, it's going to move faster, or it's going to burn brighter. Voltage is measured by volts and is abbreviated by the letter V. Voltage is really just the electrical potential of a system. That's it. It's its potential. So if I give you a 9-volt battery, that means I can give a maximum of 9 volts. Now, voltage is equal to 1 joule of energy. And if you're wanting to combine or get more voltage, then you simply add batteries together. Now, more voltage is just basically creating a stronger system or a stronger pump to force something through faster. So if you have more voltage, your current will increase. Now, this is why it matters so much about your position of your batteries. You have to have a positive and negative, and then a battery again, positive and negative, so that way the current can go through. If you have two of the same symbols matching together with your batteries, it is essentially canceling out the current, so it's not going to actually work. Last up is your resistance. Resistance will slow down the current. Resistance is abbreviated with the letter R and is measured in ohms, or this upside down looking horseshoe thing. You can kind of think of resistance as a dam holding your current back. If you add a device to a current, it will increase the resistance. And this is actually also known as a load. Anything that is added onto your circuit that will consume the electricity or consume part of the current, that is going to be considered a load. So like light bulbs or resistors, that is a load. So let's go ahead. Right down here at the bottom, more resistance equals less current equals less light. All right, so our last review was of Ohm's law. If you are not the best at remembering your algebraic equations, you can simply draw out your triangle. We've had several of these for Q equals MC delta T or for F equals MA. But if you are not good and the triangle method works, and you're going to have your V on top, I on bottom, and R on bottom. This would be our triangle for Ohm's law. So again, I is your current, V is your voltage, and R is your resistance. So we have a couple practice problems already done out for you. And the first thing you're always going to have to do is identify what you have. So in the first problem, how much current? Current is again measured in amps, and that's your I. So it's going to ask you how much current. So that's going to be your question mark. Does a 12-volt battery, again, 12 volts, we know voltage is measured in volts, so V is going to be equal to 12. R is your resistance, it's measured in ohms, so push through a 3 ohm resistor. So we've identified all three of our variables. I is our question mark, V is 12 volts, and resistance is 3 ohms. We know that our equation is I equals V over R. And so here's where they call plug and chug. You have 12 volts. You know that volts go on top. So 12 volts right here. 3 ohms is your R. We know that resistance goes on bottom. And so 3 ohms is on your bottom. So essentially it boils down to 12 divided by 3, which is equal to 4. And don't forget your units. We were calculating current, so you should have 4 amps. Something similar with our second example. Again, we're going to have to identify our variables. And we are being asked how strong a battery produces 2 amps. So again, amps tells you that you're dealing with current. So 2A goes with our I. Through a 3 ohm resistor. So resistance is in 3 ohms. That leaves us with voltage. That's our question mark. That's our unknown. Now we can rearrange Ohm's law. Use our triangle over here, cover up V. And you know that voltage is equal to I times R. So that means V equals I times R is going to be our equation that we are using. So essentially, current is 2, resistance is 3, 2 times 3 is 6. And so these are examples of our Ohm's law. Now, I'm not going to require you to do the bottom part in the lab. That can be marked off. But I am going to require you to complete this top part. And I'm going to be requiring you to complete the additional worksheet that is on this scan. So you should have this as one page, and then the other one is made up of 4 pages. So you should have a total of 4 pages to go through. And they should be fairly easy. They have a couple multiple choice. You have a couple fill in the blank. There was a word search one, so it should be fine enough. This one, though, I can go ahead and I can tell you exactly where to find the answers. This first box right here is actually in tandem together, and you are simply matching the units. So we know that force is measured in newtons, current is measured in amps, and of course, if you don't know, you can always look on the other side. So V is voltage. Voltage is measured in volts. So you can draw a line here. Or you can also write it out. 4 volts, 4 amps, 4 newtons. That should be fairly okay to no matter which way you really take care of it. I will tell you that power is measured in watts and energy is measured in joules. So that should kind of help you out there. This square right here, which one's series, which one's parallel? Right here, this is talking about your relationship. Relationship questions can all be found right here. I guarantee you all 4 of these right here can help answer these questions. This is looking at your equation, I equals V over R. So the units for current is amps. The abbreviation for current is I. The units for voltage, right here, volts, abbreviation V. So you're just kind of going in and filling in the blanks. Last question over here, will the lights turn on or off? Yes or no, why or why not? This one right here, you are simply calculating using your I equals VR equation. If you need the triangle, just draw it out to the side. And that should help you out. This last box right here, you are simply determining, is this characteristic seen in series or is it seen in parallel? So only one path for electricity, that's identifying a series. Can turn off one light without turning off others. That's an example of parallel. So that's all that we're doing with today. We're just kind of doing that final review of our circuits, or of our Ohm's law. If there's any issues, please let me know. I see that there's still some of the lab from last week that are having some issues turning it in. So again, there is the Go Guardian where you can ask me a question, and I'll be more than happy to help you. Other than that, make sure you have a wonderful day.